All right, so we know the problem and we somewhat have an idea of the solution. The problem is we want to move in the direction we're looking, not the character's forward direction. We want the forward direction corresponding to our controller's rotation, right? So that's what we're going to solve in this lecture. So let's hop back into Visual Studio and take a look at our move forward function. So here's what we're going to do. We know that rotation matrices play a role somehow, right? So what we're going to do is let's remove these lines here and let's go ahead and put a comment here and state our goal. We want to find out which way is forward. So how do we do that? Well, first of all, we want to know the controller's rotation. And there's a function called getControlRotation. So whenever we talk about control rotation, we're talking about the rotation of our controller. Now, getControlRotation is a simple function. If we right-click and peek its definition, it has this line. Now, this line may look confusing if you're not familiar with the ternary operator, but the ternary operator is simply a compact if statement. It says, if this is true, do this. Otherwise, do that. So it's like, if this, else that. Now, if this is true, that means we're basically checking to see if the inherited controller variable is not a null pointer. If this returned false, then this pointer would be a null pointer. So if the controller is not null, then we return controller getControlRotation. So the controller itself has a function called getControlRotation. And if controller is a null pointer, this function returns a 0 rotator. So that's how getControlRotation works. And if you're really curious, you can jump into getControlRotation and dig further, but no need to do that. We just know that getControlRotation returns an F rotator that represents our controller's rotation. So we're going to store this in a local F rotator variable. Now, we don't plan on changing this local variable, so we can make it a const F rotator. And we can call this control rotation and assign it the value returned from getControlRotation. Now, using const here is just a good practice. We call it const correctness if we're adding the const keyword to things that we don't plan on changing. It just makes things easier to read. We know that later on in the code, we'll never actually change anything on control rotation. And that way, if we're looking for bugs, we'll know that this never changes simply by looking at the const keyword there. So we have a const F rotator called control rotation, and we want to figure out which way is forward using this control rotation. But the thing is, though, we really don't care about pitch or roll. Let's hop back into the editor to demonstrate. If I press play and I'm moving my mouse left and right, so I'm changing the controller's yaw. If I move up and down, I'm changing the controller's pitch, right? Well, we don't really care about that pitch. If we're moving in the direction we're looking in, we want to move parallel to the ground. So we don't care if I'm looking up or down, only which direction in the yaw I'm looking at. And for that reason, we only care about our controller's yaw component of its control rotation. So we can make another const F rotator called yaw rotation, and this is going to be our control rotation with 0 for the pitch and 0 for the roll. And we can use the F rotator constructor that takes 3 inputs. We can pass in 0.f for the first, and the pop-up shows us that F rotator takes 3 inputs, a pitch, a yaw, and a roll. And for the yaw, we can use the yaw component from our control rotation. So we can say control rotation.yaw. And for the final input, that's the roll, we can pass in 0. So we have this new F rotator called yaw rotation, and it's the control rotation, but zeroed out in the pitch and the roll. We only care about that yaw, right? So now that we have the rotator we're going to use, we need to get the direction. Now, this is where rotation matrices come in. Now, there's a type built into Unreal Engine called an F rotation matrix. An F rotation matrix has several overloads. One of them takes an F rotator. Now I know these say F rotator 3D, but an F rotator type will satisfy that input. So we can pass in our rotator, which is yaw rotation. So this creates a brand new F rotation matrix. Now, if we wanted, we could store it in a local variable, or we can take our F rotation matrix and call a function on it. The F rotation matrix type contains some functions, and one of them is called getUnitAxis. Now, we're not using the arrow here, we're using the dot, and that's because our F rotation matrix here is not a pointer. We're going to use the dot to call getUnitAxis. And getUnitAxis takes an input parameter of type eAxis type. Now this is an enum, and if we type eAxis double colon, we see that among the options here we can choose X, Y, or Z. Now if we choose X, then calling getUnitAxis, this function that belongs to F rotation matrix, then getUnitAxis returns, look at that, an F vector 3D. And this vector is going to be the x-axis corresponding to our yaw rotation. So the F rotation matrix has the ability to return a vector. And essentially, we're taking a vector and its base position, essentially pointing in the forward direction, and rotating it. Think of it like taking a gizmo, right? X, Y, and Z vectors, and rotating them according to the yaw pitch and roll here in yaw rotation, and taking the X vector from that. So this quantity here returns an F vector that represents the direction our controller is looking in. We can store this in an F vector, and we're going to store it in a const F vector, and we're going to call this direction. So we create an F rotation matrix passing in yaw rotation, and using that F rotation matrix, we're calling getUnitAxis. And notice the word unit here. This returns a unit vector, a vector with a length of 1. So we have a normalized direction vector, and this vector can be used to add movement input like we were doing before. Look at move right. We're calling add movement input, passing in a direction. Now we have the direction corresponding to the control rotation, at least taking yaw into account. We don't care about pitch or roll. So let's call add movement input, passing in this direction now. And we can, of course, pass in value for the scale, just like we did before. And if we go ahead and save all, and hop back into the editor and hot reload, let's see what happens now. Let's go ahead and hit play. And I'm going to move my controller, right? And the camera will go with it. And if I press W, look at that. I'm moving in the direction I'm looking in. This is exactly what we wanted. Now, this only works for moving forward and backward, of course, because, well, we're not doing this for move right. Well, let's do that for move right. Let's go ahead and shift escape and hop back into our code and go down to move right. Now, we're going to do the same thing just about. So let's look at both of these functions at the same time. And I'm going to take my move right function and remove these lines because we want to do what we did here in move forward, which is instead of find out which way is forward, now we want to find out which way is right. So let's add a comment down here and say, find out which way is right. And we'll make a const F rotator called control rotation, and we'll initialize it with get control rotation. And we'll also make a const F rotator called yaw rotation. And we'll initialize this with 0.f, control rotation.yaw, and 0.f. Okay, so far this function looks pretty much the same. Now here's the difference. We want to get a rotation matrix and call getUnitAxis, but now we're interested in the right vector, not the forward vector. Okay, so let's make a const F vector called direction and use F rotation matrix, passing in our yaw rotation, and we're going to call getUnitAxis. Now notice, before I complete this, there's two functions here, get unit axis and get unit axes. Axes being plural. You don't want that one. You want get unit axis, AXIS. So that's something that trips up some students. Make sure you call get unit axis. And this time we're going to pass in E-axis and choose Y because Y is the right vector. X is the forward vector. So we're getting the right vector corresponding to our yaw rotation. All right. And then we're going to call add movement input, passing in direction. So let's do it. Let's call add movement input and pass in direction followed by value. And that's it. Let's hit save all and hop back into the editor. And we'll go ahead and hot reload. And let's press play. And I can hit the A key, I can hit the D key, and I can rotate around. And we're moving left and right, and we're moving in the correct left and right directions according to our control rotation's right vector. So this is great. Now, I know, the character's facing that way, and we're moving that way, and they're kind of moonwalking, and it doesn't look great, but we can easily fix that. If we want our character to orient towards our movement, there's a variable for that. We can go into BP/character and select our character movement component and search for orient. And here's another Boolean variable. It's called orient rotation to movement. Let's see what happens if we check that and press play. Now, if I hit the D key, look at that. I'm rotating in the direction of the movement, and I'm doing so smoothly. I'm not just snapping towards the rotation of the movement. We're actually orienting slowly towards that direction. And how slowly is a parameter we can change. We can go back into the details and we can search for rotation rate. And rotation rate has X, Y, and Z, and these are speeds about these axes, showing how fast we should move. So if you wanted to rotate towards movement faster, we would change this 360 to something higher, like say 1500. Now if I press play, now I'm rotating in the direction of movement very quickly, which doesn't really look that natural, right? I think 360 is a pretty good value for this. So we're going to keep that. All right, so now that we're orienting in the direction of movement, well, we changed a variable on the blueprint itself, specifically on the character movement component. Now, we'd like to be able to do this from C++, so let's see how we can do that. We're going to go back to our project, up into the constructor, and what we can do is access our character movement component. And characters have a built-in function called getCharacterMovement. And if we hover over this, we see that its type is uCharacterMovementComponent. Now, this function returns our character movement component if we have one, and we can use this to set properties on the character movement component. Now, if we want to use our character movement component for accessing functions and variables, that means we need to include the header type for uCharacterMovementComponent. So we're going to jump into the documentation and search for uCharacterMovementComponent. And we'll click the first thing that pops up, uCharacterMovementComponent. And down here we have our include. It's in Game Framework, and it's called CharacterMovementComponent.h. We copied that line, and we're going to paste it here in /character.cpp. And now we can access functions and variables on the character movement component. So let's add an arrow, and the first thing I'm going to look for is B-orient. And look at this, B-orient rotation to movement. We're going to set that to true. And we can also call getCharacterMovement and type rotation, and here's that rotation rate. Now, if we hover over it, we see that it's an F rotator. And we can set this by constructing a fresh F rotator, passing in yaw, pitch, and roll. And we're interested in the yaw. So if we set this to, say, 400.f for the yaw, then we can see what this looks like in the editor. I'm going to go ahead and close out of the editor and get a compile and a launch. And reopening our character blueprint. I'm going to select my character movement component and search for rotation. And there's my rotation rate, and you'll see that now that Z component is 400. So it's kind of strange. It's listed as X, Y, and Z. These are the axes about which our character rotates. And we know what yaw, pitch, and roll do. We know that yaw is a rotation about the Z axis. So that's how I knew that this was going to be the Z axis here. All right, so, and we can press play, and we rotate a little faster, not much faster. It was already 360, now it's 400. But now we're setting it from C++. All right, so great job. Now, we still have some work to do. The character just slides. They're not running around. We need to have some run animations. We'll do that very shortly, but you might be bugged a bit because the character's hair is not there. And we want that hair because it's a beautiful, beautiful hair asset. And we're going to stick that on the head in the next video. I'll see you soon.